Under the theme of designing a piping system, I would like to explain the basics of a piping system. First, I will talk about water pipeline system and selection of pumps. The contents I will explain are shown on this slide. The water pipeline system is the most commonly used piping system in air conditioners. There are several water pipeline systems, including the cold water pipeline system for cooling, the hot water pipeline system for heating, and the cold-hot water pipeline system used for both cooling and heating by changing its mode depending on the season. In addition, the cooling water pipe system is used to remove heat generated from the heat generator and the heater. Here, first, I am going to introduce the basics of some piping systems and piping fittings in water pipeline systems. 1. Piping systems. Closed circuits and open circuits. You probably already know them, but I will talk about the basics of closed circuits and open circuits. A closed circuit is defined as a circuit whose circulation path of water in the water circulation pipeline system is not open to the air. On the other hand, an open circuit is defined as a circuit whose circulation path ends upon contact with a part of the system like a water tank open to the air. You can see a simplified flow of a closed circuit on this slide. Water circulates through this path. There are no parts open to the atmosphere in the circuit. Open circuits include open-type cooling towers and open-type heat storage tanks. Schematic drawings of open circuits are shown on this slide. Water circulates along this path. A water tank open to the air is connected to the circuit. Disadvantages of open circuits. When you select between a closed circuit and an open circuit for a cooling heating water pipeline system, you must decide overall based on load conditions, usage, maintainability, and construction conditions. In general, open circuits are inferior to closed circuits for the following reasons. 1. An open circuit is subject to not only the pressure determined by the pump head but also the pressure determined by the actual lifting height. Pumps used for open circuits need more power than those used for closed circuits. 2. Circulating water makes contact with the air, so more oxygen is dissolved in the water, and pipes are likely to corrode. So you must take measures to prevent pipes from corroding. 3. An open circuit can be contaminated from the opening. Before you use an open-type heat storage tank, you should thoroughly confirm the effectiveness of the tank. In addition, you must make efforts to reduce the pumping power as much as possible. 2-pipe systems and 4-pipe systems. The 2-pipe system is a system which sends either cold water or hot water to equipment on the load side. The 2 pipes are the supply pipe and the return pipe. The 4-pipe system is a system which sends cold water and hot water separately to equipment on the load side. In some cases, 2 coils are separately installed on equipment on the load side to separately provide hot and cold water. In other cases, 1 coil is installed on the load side which can be switched to provide either cold water or hot water. In the past, the 3-pipe system was also used. This system separately sent cold water and hot water by using two supply pipes. The return pipe, however, was used for both cold and hot water. Since the system caused a great loss of water by mixing the two, the three-pipe system is not used today. Direct return systems and reverse return systems. Water piping systems include direct return systems and reverse return systems. As shown on the slide, the direct return system is a system which returns water to the heat source without extending the return pipes. Water in pipes flows at a higher rate as it flows close to equipment close to the heat source. A predetermined quantity of water may not pass by distantly connected equipment. Different from the direct return system, the reverse return system is used when a lot of the same equipment is arranged. The purpose of this system is to improve the balance of the flow rates of water passing by different apparatuses by applying piping resistance to those apparatuses. As shown on the slide, the reverse return system is a system which returns water to the heat source by extending the return pipes near the heat source to the most distant equipment. The lengths of the pipes to each apparatus are approximately equal to each other. The flow rates of water passing by each apparatus are better balanced. The reverse return systems use pipes arranged horizontally on each floor or vertically to each floor. If equipment resistances applied to each apparatus are approximately the same as each other, the reverse return system works effectively. On the other hand, if equipment resistances applied to each apparatus are different, the reverse return system works less effectively because you must adjust the flow rates on an equipment-by-equipment basis. Primary pump systems and secondary pump systems. The primary pump system uses one pump in a single path, while the secondary pump system uses two pumps in a double path. As shown on the slide, the primary system is simple. Water is sent from the heat source to equipment on the load side by one pump. On the other hand, the secondary pump system sends water separately to the heat source and equipment on the load side as shown on the slide. The primary pump is used to send water to the heat source. The secondary pump is used to send water to equipment on the load side. The circulation through the heat source is secured by the primary pump, while the flow rates of the water sent to the load side are adjusted by the secondary pump. Constant flow systems and variable flow systems. The constant flow system circulates a constant quantity of water through the circuit. On the other hand, the variable flow system changes flow rates of the water flowing through the circuit based on loads and other factors. A constant flow system is on the slide. The system controls air conditioning loads by using a three-way valve. The quantity of water sent to coils is controlled based on the loads and the uncirculated remaining water is bypassed. By bypassing the water, a constant amount of water is always circulated. The variable flow system controls air conditioning loads by using a two-way valve. The quantity of water sent to coils is controlled based on the load. A bypass tube is installed between the supply pipe and the return pipe on the heat source side. The quantity of water therefore is secured by the bypass tube. On the secondary side, another bypass tube is installed to reduce pressure in grease. Recently, this variable flow system is combined with heat sources, revolution speed controllers, and multiple unit controllers. Two, piping fittings. Piping fittings include valves and joints. Here, I will give you a brief explanation about expansion joints and air vent valves. Expansion joints. Pipelines expand and contract depending on the temperature change. If you do not pay attention to how to absorb expansion and contraction of pipes, the pipes may break. In addition, broken pipes may damage the building. The degree of expansion and contraction of a pipeline. The degree of expansion and contraction of a pipeline can be calculated using the calculation method shown. As an example, let's calculate the degree of expansion and contraction of a hot water pipe as shown on the lower side of the slide. If you put the conditions shown on the slide into the equation, the calculated degree of expansion is 17.25 millimeters if the length of the pipeline is 30 meters. Types of expansion joints. 3 types of joints to absorb expansion or contraction are shown on the slide. Here, I will explain expansion joints which are often used. Expansion joint fitting. Expansion joints absorb the displacement in the direction of the pipe axis. Based on the structures of the joints, there are 2 types, bellows type and sleeve type. Based on the absorption methods, there are 2 types, single type and double type. The single type joint absorbs the displacement of the pipeline on one side. The double type joint absorbs the displacement of it on both sides. If you want to absorb the expansion and contraction by using expansion joints, set an appropriate section for expansion and contraction and firmly anchor both ends of the section. Piping support guides are used for expansion and contraction occurring in the direction of the pipeline axis. For single type joints, the arrangement of the 6 points and guides are as shown on the slide. This drawing was extracted from EC data. 6 points. The position of the single type joint is shown in the upper drawing on the slide. The joint absorbs expansion and contraction occurring along the line between the 2 arrows. The position of the double type joint and flow guides are as shown in the lower drawing on the slide. This drawing was also extracted from EC data. 6 points. The position of the double type expansion joint is as shown in the drawing. The joint absorbs expansion and contraction occurring along the lines between the arrows. Air vent valves. The air trapped in the pipelines may corrode pipes and cause malfunction of equipment. Air vent valves are installed at places where the air likely to accumulate, including the top of the pipeline. Takeshaw Limited makes a product called Aglavent Mark II. It removes air in the pipeline more quickly. Basically, the air vent valve is installed at the top of the pipeline because the air is likely to accumulate there and the pressure is low. The drawings on the slide are extracted from Do's and Don'ts on Piping, Becker as a shoe. 3. Selection of pumps. After the piping system and paths are determined, and piping attachments are arranged, a piping drawing is prepared. Based on the piping drawing, the piping resistance is calculated to determine the pump head. Pumps are selected based on the required quantity of water and the pump head. Here, I am going to talk about some basics necessary for pump selection. Types of pumps. If you classify types of pumps based on operating principles, you will find that there are many types as shown on the slide. Pumps used at construction facilities, however, belong to the centrifugal type of volute pumps as shown in the upper table on the slide. If you classify them based on structure and application, the classifications are shown in the lower table on the slide. Types of impellers. Types of impellers are classified as shown in the table on the slide. Different impellers are used based on the fluid to be used and their application. Shaft seals. A shaft seal section is installed on the shaft through the hole in the pump casing to prevent leakage of fluid and absorption of air. Shaft seals are roughly classified into two systems, the gland packing system and the mechanical seal system. The gland packing keeps just enough water for it to drip out. The leakage lubricates and cools the sliding portion of the packing. The sealing water system includes the external injection system, which injects water from the outside, and the self-injection system, which introduces some of the discharged pressurized water. A mechanical seal prevents leakage by allowing a revolution ring to revolute together with the axis, and by allowing a fixation ring fixed to the backing to slide on a sliding surface perpendicular to the axis. The quantity of leaked fluid is very small, so you cannot confirm it by sight. For a sealed piping system, it is important that water does not leak, so be sure to use mechanical seals for sealed piping systems. Changes in pump performance. Changes in performance based on revolution speed. If the revolution speed is changed, the performance of the pump also changes. The quantity of water changes in proportion to the change in revolution speed. The pump head changes in proportion to the square of the change in revolution speed. The motor power changes in proportion to the cube of the change in revolution speed. As previously explained, the pump inverter control, revolution control, used in the variable flow system is to save energy based on changes in performance caused by the change in revolution speed of pump. For the variable flow system, the two-way valve is used to change the quantity of water to be sent to the coil based on room load conditions. As room loads are reduced, the water to be sent to the coil should also be reduced. Changing the quantity of water makes the pump adjust its capacity corresponding to loads possible. Different from the constant flow system with the three-way valve, the pump operating point of the two-valve variable flow system varies along with changes in the quantity of water. Referring to the performance curves in the chart on the right side, the valve is fully opened at the peak load with a flow rate of QO and a pressure of P1. So the operating point is at point AO. Let's assume that the load is reduced and the quantity varies from point QO to point Q1. As the flow rate is reduced, the operating point shifts from point AO to point AO apostrophe. The flow rate is changed by restricting the two-way valve's opening to apply resistance to the piping system. On the other hand, For the inverter control method, the revolution speed of the pump is changed by the inverter. As a result, the pump performance is adjusted to correspond to the resistance of the piping system. Inverter control methods are divided into constant discharge pressure control and constant terminal pressure control. Constant discharge pressure control is the method used to keep the discharge pressure constant. The revolution speed point shifts from point NO to point N1, and the operating point shifts from point AO to point A1. The constant terminal pressure control is the method used to lower the discharge pressure only by the quantity of water corresponding to the piping resistance. The revolution speed is shown at point N2, and the operating point is shown at A2. The power changes by the cube of the change in revolution speed, so energy can be conserved. In short, inverter control methods provide a necessary flow rate with necessary power. Changes in performance based on the blade diameter. If the blade diameter of the general volute pump is changed, the quantity of water and pump heads change in proportion to the square of the change in the blade diameter. In addition, the pump power changes in proportion to the fourth power of the blade diameter. If you change the blade diameter, you will get various kinds of pump performance. Typical performance curves. A typical performance curve for a pump manufactured by Ebara Corporation is shown on this slide. Individual values and curves represent descriptions on this slide. Cavitation. When the static pressure of some of the fluid becomes equal to or lower than the vapor pressure corresponding to the fluid temperature at that time, the fluid is vaporized locally to generate air bubbles. This phenomenon is called cavitation. For centrifugal pumps, cavitation is likely to occur at the impeller inlet. If cavitation becomes more severe, noise and vibration are generated, and pump performance and efficiency drop. As a result, water cannot be sent. Additionally, if a pump is operated while under cavitation, severe corrosion occurs at the cavitation-generated portion and causes the pump to break down. To prevent cavitation, the effective suction head must always be larger than the required net positive suction head. This is very important. You can read the value of the required net positive suction head from the NPSH curve shown in the performance curve chart. The net positive suction head is determined by calculations based on operating conditions. The net positive suction head is described in relation to the pump suction head in the EC data. The greater the resistance of the suction tube, and the hotter the water, the smaller the net positive suction head becomes. Cavitation is therefore likely to occur when the resistance of the suction tube has increased or when the temperature of the water is high. When hot water is pumped up from the heat storage tank, confirm the net positive suction head and the required net positive suction head. Cavitation is likely to occur around the cooling tower. Cavitation is likely to occur if the piping resistance on the suction side has increased. It may be caused by the staining or clogging of the strainer. In addition, cavitation also easily occurs if a control valve is installed on the suction side. You must sometimes confirm the net positive head and change the setting height. Allowable charge pressure, allowable back pressure of pumps. Like circulating pumps and cooling water pumps, when charge pressure is imposed on the suction side, you must check the allowable charge pressure of the pump. The pressure corresponding to the height of the water column is imposed on the pump suction side. Higher pressure on the suction side causes problems such as excessive leakage of water from the shaft seal and poor pressure tolerance on the casings. Allowable charge pressure is therefore predetermined for individual pumps. You should confirm the specifications of the relevant pumps, which describe measures to be taken to respond to high charge pressure. Surging. When surging occurs, pump operation becomes unstable and causes noise and vibration. In addition, required performance cannot be achieved. You can see the displacement of the operating point on the pump performance chart as being at a significantly slow cycle of 0.2 to 10 seconds. Causes of surging include the following factors. 1. The operating point is shown in the area where pump performance characteristics give an upward curve on the chart. 2. There are some dead air spaces in the piping system. 3. The flow rate is adjusted by using the valve downstream from the dead air space. If you refer to an operating point in the area where pump performance characteristics are represented by an upward curve on the chart, it means that the operating point is at point B on the slide. If the operating point is at this position, the pump is unstable due to pressure in the pipeline and flow rate variation. As a result, the operating point of the pump goes back and forth between maximum point C and minimum point D. To prevent surging, select pumps whose operating point is shown in the area where pump performance characteristics are represented by a downward curve on the performance chart, as indicated at point A. You should select a pump so that only one point intersects at the performance curve with the coordinate line of the required total head. Key points when selecting pumps. Additionally, the following descriptions are general key points to keep in mind when selecting pumps. 1. Check the fluid to be used. You must prepare pump materials and structures based on the fluid types to be used. Therefore, check the specifications of the relevant pump issued by the manufacturer to confirm the type of fluid. Only select pumps which can use that fluid. 2. Check the temperature of the fluid to be used. If the temperature of the fluid is high, the pump may break down due to overheating of bearings and shaft seals and distortion due to thermal stress. Confirm the allowable temperature range of the relevant fluid described in the specifications. 3. Check the specific gravity of the fluid to be used. If the specific gravity of the fluid to be used is not 1, the corresponding pressure and shaft power should be changed. General pump selection guides describe pump performance when the specific gravity is 1. So, if you want to use fluid with a specific gravity greater than 1, such as brine, you need to set the shaft power to that greater in proportion to the specific gravity. 4. Check the viscosity of the fluid to be treated. If you use a fluid with high viscosity, such as brine, the performance is affected by the fluid. The pump head, quantity of water, and shaft power vary with increased viscosity. This is the end of the explanation of water pipeline system and selection.